The steam turbine is one of the most critical assets in a power plant, and the turbine bypass system protects it in many ways. During plant startup, it takes time for the HRSG to produce the steam quality needed to efficiently generate power. During this period, the boiler produces highly saturated steam that, if not diverted, will damage the turbine. The turbine bypass valve diverts the low-quality steam away from the turbine to the condenser, protecting the turbine blades from water impingement and erosion. As steam flows through the turbine bypass valve, water is injected into the outlet pipe to cool the steam to the desired temperature for reheating or condensing. As the HRSG continues to heat up, steam flow increases through the bypass valve. The bypass valve must regulate the system pressure while controlling the outlet steam temperature. Once the steam temperature and quality are suitable for power generation, the bypass valve closes, sending steam to the turbine. In the unlikely occurrence of a plant trip, the turbine bypass valve must open very quickly to avoid overpressurization of the system and prevent damage to the turbine. To ensure long-term efficiency and reliability of a power plant, it's critical to choose a turbine bypass valve system that's robust enough to endure daily startups, shutdowns, and potential system trips, while always maintaining tight shutoff. The Mason-Nealon SteamForm valve is custom engineered to be a robust and trouble-free system, ensuring reliable shutoff and easy maintenance. It's available with a bolted bonnet or pressure seal. Engineered using high-strength materials and proven technology, the Mason-Nealon SteamForm valve is based on over 50 years of successful field experience in various industries. Offered with a wide range of actuator options, including pneumatic and hydraulic systems, it can be adapted into almost any steam conditioning application. All Mason-Nealon valve bodies and desuperheaters are designed to exceed the requirements of ASME and PED, with emphasis on thermal stress, material creep, and external pipe loading. The Mason-Nealon pressure seal bonnet utilizes a hung cage design, allowing free expansion of the trim during thermal transients, while maintaining excellent guiding of the control trim. The control trim uses high-quality, hard-faced guides and a seat constructed from high-strength stellite, ensuring long life and serviceability. The Mason-Nealon pilot plug is comprised of only a few well-captured parts. Using a custom closed-ground coil spring with a heavy retainer, the pilot design avoids using commercially available springs and fasteners inside the valve, which can loosen or break during operation. The pilot system uses active pressure engagement, which keeps the stem in tension at all times during operation, resulting in excellent plug stability. Metal-to-metal sealing at the main plug and pilot plug ensures repeatable Class 5 shutoff. The Mason-Nealon bolted bonnet design uses a fully removable quick change trim, which is securely clamped within the valve body. This design utilizes a custom spring seal that's clamped in series with the valve trim. When the process temperature increases rapidly, the spring seal relieves potential stress associated with thermal growth of the cage. This helps avoid trim sticking issues tied to uneven thermal expansion of trim components and the valve body. All Mason-Nealon SteamForms are designed with low dB technology, which efficiently reduces pressure and noise through the valve. Thick-walled, pressure-reducing stages are strategically packed with precision-drilled holes and optimized for each application. The Mason-Nealon Flow Profiler improves desuperheating performance. Its patented design diverts the flow stream toward the center of the pipe and shields the spray nozzles from the steam flow. This allows the spray water to penetrate further into the flow stream, helping prevent water fallout and water impingement on the pipe walls. Turbulence created downstream of the flow profiler improves mixing and temperature distribution in the pipe. This reduces the time required to fully vaporize the spray water, thereby reducing the required downstream pipe length in the system. Mason-Nealon SteamForm valves are custom engineered for each application, and offered with a wide variety of trim options to meet virtually any application. There are a variety of commissioning options for turbine bypass applications, including blow-through and blowout kits. For plants that require an isolation valve in the bypass line, there's also a high-capacity Mason-Nealon auxiliary shutoff valve that's tailored to the bypass system. When you need a valve with long-term efficiency, reliability, and ease of maintenance, the Mason-Nealon SteamForm can definitely deliver. It's a true engineered solution, developed by an industry leader in control valve technologies.